Hey there, science explorers. Ever made a volcano erupt with baking soda and vinegar? That's a chemical reaction in action. Chemical reactions happen when substances called reactants transform into new substances called products. It's like rearranging Lego blocks to create something new. We use chemical equations to represent these reactions. It's like a secret code for scientists. For example, the reaction between hydrogen and oxygen to form water is written as 2H2 plus O2 gives 2H2O. Remember the law of conservation of mass? It states that matter cannot be created or destroyed, only transformed. So, the total mass of the reactants always equals the total mass of the products. It's like a magic trick, but with atoms. Chemical reactions are happening all around us, from cooking to digestion. They are the building blocks of our amazing world.
Just like there are different types of parties, there are different types of chemical reactions. Let's explore some of them. 1. Combination reaction. Like a group of friends coming together, two or more reactants combine to form a single product. Example, burning magnesium ribbon in the air. 2. Decomposition reaction. Think of a puzzle breaking apart. A single reactant breaks down into two or more simpler products. Example, heating calcium carbonate to produce calcium oxide and carbon dioxide. 3. Displacement reaction. Imagine a game of tag where one element takes the place of another. A more reactive element displaces a less reactive element from its compound. Example, iron displacing copper from copper sulfate solution. 4. Double displacement reaction. It's like a partner swap. Two reactants exchange ions to form two new compounds. Example, reaction between sodium chloride and silver nitrate to form silver chloride and sodium nitrate. Understanding these types of reactions helps us predict what might happen when different substances mix. It's like having a chemistry cheat sheet. Acids, bases and salts are like the rock stars of the chemistry world. They play crucial roles in our everyday lives. Acids, these are substances that taste sour, like lemon juice. They turn blue litmus paper red. Strong acids can be corrosive, so handle with care. Bases, also known as alkalis, these substances taste bitter, like soap. They turn red litmus paper blue. Strong bases can also be corrosive. Salts, these are formed when an acid reacts with a base, a process called neutralization. Salts are generally neutral, meaning they are neither acidic nor basic. Table salt or sodium chloride is a common example. The pH scale measures how acidic or basic a substance is. It ranges from 0 to 14, with 7 being neutral. Acids have a pH less than 7, while bases have a pH greater than 7. Understanding the properties of acids, bases and salts is crucial in fields like medicine, agriculture and environmental science. Let's dive into the world of elements. Elements are the basic building blocks of matter. They can be broadly classified into metals and non-metals. Metals are shiny, malleable and ductile. They are good conductors of heat and electricity. Think of metals like iron, copper and gold, non-metals. Non-metals, on the other hand, are generally dull, brittle and poor conductors of heat and electricity. They can be gases like oxygen and nitrogen, liquids like bromine, or solids like carbon and sulfur. The reactivity series is a useful tool that ranks metals based on their reactivity. Metals higher up in the series are more reactive than those below them. Metals and non-metals have a wide range of applications in our lives. From the construction of buildings to the manufacturing of electronic devices, these elements are essential.